Hello, 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 everyone. Thank you for
Welcome.
saying hi in the chat. Yeah, and if you're in the chat, say hi, say where you're from, say what time it is for you so that we can see how global everybody is, where everybody's coming from. But I'll just do some introductions. I'm Pamela Fox. I'm on the Python Cloud Advocacy team, and I'll be giving several of the presentations for this hackathon because this is something I work with all the time, and I'm really, really excited to be able to share it with all of you.
And I'm Josh O. I work as a cloud advocate PM, and I work very closely with Pamela with the Python team. And I'm really excited to be working with all of the speakers and getting everything behind the scenes set up. And I'll also be here in chat answering questions as we go through each of the sessions.
All right. So thank you, Josh. And thanks everyone for coming again. I will say I did get a cough over the weekend, so I apologize if my voice gets a little weird at times, but I do have a whole freaking teapot here. So, hopefully we'll do all right. So yeah, here are the slides. I'll share these slides after, but we'll also share all the links in the YouTube description and also, during in the chat. So our goal is to, share everything that we have with you all so that we can set you up for success. So this is what we're doing for the next 2 weeks is the AI chat app hack. And we've got sessions almost every weekday. And sometimes we even have 2 sessions. So today this is our kickoff session in English. And then there's a session later at I think 2 or 3 about Cosmos DB connection. And then we've got sessions all throughout the rest of the week and next week. And there are also sessions in Portuguese, Spanish, and Chinese. So if you're more comfortable with any of those languages, check out those sessions. They're linked from the README. But we're hoping that we can share a lot of what we know with you so that you can start figuring out how to make ragchat and make things that are really cool. And then at the end of the hackathon on February 12th, that is when you'll submit your project. And we're also going to have another live session then, a show and tell. So we're hoping that some of you will want to, let your creations be shared with the world so we can show them. And we're also going to show and tell some cool stuff that we've worked on. So there is the schedule. You can get all of the session links from the README. So, from this README here, AI chat app hack, you can find all of the session links here, and you can even, subscribe to each of the YouTube links to be notified. And here's the non-English sessions here. There's also an ICS file that you can add to your calendar. And if you register for the hackathon, and hopefully all of you have registered, but if you haven't, please do register. Then we'll also email you some of these links as well. So lots of ways to stay up to date with what we are doing. Okay, so I'm going to go into it. How do we build a RAG chat app? So since we are from the Python Cloud Advocacy team at Microsoft, we are going to be building using Azure technologies where it makes sense. So I'm going to be showing you, and we're all going to be showing you throughout this whole thing, how to build off this particular repo that uses Azure AI Search, Azure OpenAI, and Python. But it is possible to build these chat apps with many different technologies. So if there are different things that you're comfortable with, we'll try to give you pointers as well. So our goal is to build an AI chat app using the RAG approach to combine an LLM with your own data. So now let's break down what I just said there. Some of you may not know RAG, you may not know LLM. I'm going to break that down now. If you already know that stuff, awesome. Then you can help answer questions in the chat. But if you don't, here's your introduction. I want to make sure we're all on the same level. So first, let's talk about LLMs. An LLM is a large language model. It is a model that is so large that it manages to achieve general purpose language understanding and language generation. And you can see these charts here for Lambda and GPT-3 and Palm and some other models. And what they show is that as the model scale goes up, and this is measured in terms of the training flops, which is floating point operations per second. So in terms of, how much scale it takes to train the model, what they see is that there's a certain jump where when you put enough effort into training the model, then you end up getting this huge jump in accuracy at all these tasks. So you can see accuracy at modular arithmetic, at multitask natural language understanding, and then at word in context. So ultimately, large language models, you can think of them as, next word predictors, or as they can be called, like, fancy autocomplete, but they're like really, really good at next word prediction. They're so good that they can be used for a large number of tasks. Right. So, for example, we used to write specialized sentiment classifiers to say whether something was positive or negative, but you can now use an LLM for it if you want. So you just have to give the LLM an example to get it to, complete. So here we say, we give an example of this movie sucks, sentiment is negative. Review, I love this movie, sentiment. And then we pass this to the LLM, and the LLM is a very good next word predictor. And in this case, that means it's going to classify the sentiment of that review, and it'll say positive. So this example, where before we would have built specialized models for it, and in this case, an LLM is so powerful that it's able to be used for that purpose. Now, we can still build specialized models. Like, LLMs aren't going to replace everything, but this is just to demonstrate how impressive they are and what they can do. So here's some LLMs in use today. The most commonly known ones and used ones are the GPT series from OpenAI. So GPT-3.5, GPT-4, and I heard some rumors of GPT-5 on the horizon, but maybe far off. And one way to think about these models in terms of how many parameters, a lot of times that's a measure of, their power, their size, or at least how much training went into them. So with GPT-3.5, it's 175 billion. For GPT-4, it's actually undisclosed. So we, just speculate there. But those are used all over the place. They're used for ChatGPT. They're used for Microsoft Copilots, like GitHub Copilot. And they're also, of course, available via APIs. And that's what we'll be using in our projects. There's also Palm, which came from Google, that's used for Bard, and I think also probably in APIs. Claude 2 is from Anthropic, and they have APIs for that. Then there's also open source models. So there's Llama from Meta, and Mistral 7B. This came out fairly recently, but it's said to be fairly good, and that's from Mistral AI. So this is a hot space, and there's more models coming out today. And probably this table is already out of date. I made it last week, and it's probably already out of date in some respects. So, we got to keep our eyes on what's happening in this space, and seeing how people are building on these LLMs and building new LLMs. So one thing I want to talk about was GPT, because this is a specific kind of model, I should say transformer. So generative pre-trained transformer. There is a particular kind of LLM, and it's based off of the transformer architecture. And there's a paper that introduced this concept called attention is all you need. And this is a diagram from the paper here. And this was actually from the Google Brain team. So the Google Brain team wrote this paper originally, and then other teams, from other companies like OpenAI, they just, went full steam ahead with this transformer concept. So they used that transformer architecture in order to make the GPT models. And lots of these other LLMs do also use some sort of transformer architecture, but they don't all. So I just wanted to explain, what does GPT stand for, or if you see transformer, what are they talking about? It's all about this original paper. And if you want to get really deep into it, Andre Karpathy, who works at OpenAI, has amazing videos where he gives overviews, but then also videos where he builds GPT from scratch, just in Python notebooks. And so if you do have, 10 hours free at some point, I do recommend his videos to really get into it and see the nitty gritty of how you'd actually build a GPT. So we're going to be using the OpenAI GPT models. How can we do that? So one way you can get started is just in the Azure OpenAI Studio. So let me actually just open that up so we can see. So let me go and do a chat playground here. All right, so chat. So we could say, write a poem about a cat that hates tuna. I have a 4-year-old and a 1-year-old, so a lot of my tests are just things that would entertain them. It's like a really long poem. It's in a world of whiskers and feline grace, there lived a cat with a particular taste. While most would swoon for a dish of fish, this feline friend had a different wish. It's really good. So if you need entertainment for your small children, these GPT models are very good for that. So what you can see here is that, we have the user message and then the response. We also have what's called the system message. So the default system message here is you are an AI assistant that helps people find information. But we could change that if we wanted to just change the overall tone, like you are an AI assistant that, speaks like a cat and, interleaves cat references and meows into all answers. Okay. And then, so let me save this. Let's see, apply changes. Okay. Here we go. All right. I'm going to clear this chat. Okay. And I'll say, what's a good place to eat in Seattle? Let's see how the system message worked. Here we go. Meow. Seattle is a perfect place to find some delicious treats. One terrific restaurant to check out is the Perfect Palate. They serve a variety of mouthwatering dishes. Whether you're craving seafood sushi or a tasty bowl of kibble. So really good. So that's the system message. And so this is, generally for affecting the overall tone and like answer formatting. If you wanted to answer with particular formats, like using like a JSON or something like that, that's what you would usually put in the system message. So this is what you can do in the chat playground. And this is all in the OpenAI studio. So it's a little confusing right now because Azure has an OpenAI studio and also an Azure AI studio. And I think you can get to this from both of them. I do see some questions in the chat about getting access to Azure OpenAI. Right now, you can't get access if you have an Azure free account, which I think is also an Azure student account. However, you can do everything we're showing in API wise with OpenAI.com. So I use the OpenAI stuff all the time too. So you can sign up for OpenAI and you can like sign into their API portal here, API, and here. Oh, and they even have a playground. So yeah, write a poem about a cat who hates dogs. Okay. And then let's see. I've never actually used their playground, but they seem to have a playground as well. And you can get like your API keys here and stuff like that. So so everything I'm showing, you should be able to do with OpenAI. You can see I try not to spend very much, 8 cents. Very good. I do only $10 a month for OpenAI. All right. So the point I want to show here is system message plus user message. And we're going to use the same pattern in the API. So this is what it would look like in the API. So we would bring in the OpenAI SDK. And here we can say, okay, we're going to make a chat completion. And we say whether we want to stream the response or not. And then we pass in the system message. Okay, so we say role is system and then content. This one says you are a helpful assistant with very flowery language. And then we pass in the user message, role user, content, what food would magical kitties eat. And then it would, show everything that came out. So this is how we can use it from Python. And this is what we use in our repository. So it's the same thing where we got that system message and we got that user message. See if we have, okay. All right, so those are LLMs and those are really cool. But one thing we can point out is that here, when we asked about a good place to eat in Seattle, it recommended the Perfect Palate. I bet you that was made up. I don't think there's something called the Perfect. Oh, maybe it is. No, I don't think there's something called the Perfect Palate in Seattle. It looks like it might exist somewhere, like as an Instagram account. But it did make that up. And that's the thing about LLMs is that they are very good at making stuff up, which is great when you're trying to get them to write a poem, but not great if you're actually trying to get accurate information, right? So an example here is if I tell it to write a model class using the latest version of Flask SQL Alchemy, which is a Python package, and then it very happily gives this example of a model class using the latest version, but this is actually wrong. This is not the latest version. This was the version from a couple of years ago. And that's because this LLM was trained on, data up to a certain point, up to like 2021 or something like that. and it hasn't seen anything past it. So if we're trying to get it to use the latest version and it's literally never seen it, well, then it's going to give us outdated stuff. So generally it has outdated public knowledge because it was trained to a particular point. Another example here is if I asked about internal data. So if I say, do my company perks cover underwater activities? It doesn't know who my company is. It doesn't know anything about my company perks. So it's just going to give this really generic response because it has no way of accessing this information. So this is the limitation of LLMs. And this is also like, it makes sense. Like LLMs weren't designed to be knowledge experts. They were designed to be language models. So very good at language, but not necessarily very good at knowledge. So our goal is to make them good at knowledge. So how can we incorporate domain knowledge? There are 3 general approaches that people use. The first one is prompt engineering, and prompt engineering means like actually changing that system message. So we might say like, in the system message itself, we might say like, make sure you only reference restaurants that really exist. We could try to tell it to do that, or even give it a small list of restaurants like, Pike Place or something. So we could try to do that. So sometimes you can use prompt engineering to get an LLM to skew its answer towards being more accurate, but that's only going to work if it actually does have that accurate information somewhere inside of it. And if it's just really got enough information about that particular piece of knowledge so that it can fit that way. So prompt engineering can be helpful, but it's not usually how we would incorporate domain knowledge. Now, another approach on the extreme is fine tuning. This is where we have an existing model and we say, okay, we're going to fine tune the weights of that model, right? So the weights are all the weights on the neurons. And we're going to do that by giving it like another, 2000 examples of things it should know. So you could go and pass in all these examples of things that you know or ways you want it to answer. And then it would end up fine tuning its weights. So that's a way of getting an LLM to learn new skills permanently because you've updated all its weights. And so it will always have it in its weight. And so it can definitely work. However, it's got big drawbacks in that it's expensive to do the fine tuning. And it's also more expensive to use a fine-tuned model. So it's going to cost you more, per generation, per response to use that fine-tuned model. So you have to really want to use fine-tuning, which is why we typically recommend Retrieval Augmented Generation, or RAG, which is a way of giving it new facts temporarily in order to answer this current question. So that's what we're going to focus on for this hackathon, is using RAG. It's a very powerful technique. It's used, increasingly by all the co-pilots out there, and it's something that you can use to make, really helpful chatbots. So let's go into RAG. So this is generally how it works. So the user asks a question, right? Like, do my company perks cover underwater activities? We take that question and we use it to search a knowledge base, right? So in this case, some internal knowledge base that knows about company perks. And then we take both the original user question and the chunks of knowledge that we got from that knowledge base, and we send that to the large language model. And then the large language model, and we tell that large language model, like, hey, here's the question, here's the sources. Answer this only according to the sources. Stick with the sources. And so that LLM says, oh, yes, your company curves do cover it. Here's some example. Here's a citation, right? So a good hint that you're using something that's using RAG is if you see citations, because that means it's actually grounded in some sources, some data sources, and it's referencing those data sources. So that's our goal, is to be able to have a citation so we can follow and verify, yes, that answer, it gave that answer for a good reason. And the user can, if they want to, they can look into that source and verify it further. So we can go ahead and look at this actual example. I think this is the one I just deployed. All right. And what was the question? Do my company perks cover underwater activities? Looks like I've got a spelling issue there, but that's okay. And let me also, I just deployed a bunch of these this morning, so we'll just try it in a few different ones. So this is the RAG we'll be building off it, but do my company perks cover underwater activities. Let's see that one. Okay, this one I probably didn't put the sources in correctly. Let me try this one. There we go. I think I must have done this with my vectors off. Okay. Oh, here we go. This is one where I asked it earlier this morning. Okay. So do my company's perks cover underwater activities? So let's see. It would said, so it's giving us a citation here and it's linking to here. Yeah, so it's saying that, to check here. And so here we can see scuba diving lessons. So in this case, it like didn't have 100, it wasn't 100% sure whether it specifically covered underwater activities, but it found the right source to say, oh, okay, here, take a look at this. And you could look at it as a user and say like, okay, scuba diving lessons. So the way this worked was that we got the supporting content, right? So this is what we found in the knowledge base, right? This is what we found in our search, is that we found, oh, okay, this bit of information, this bit of information, and this bit of information. And so then we take those three sources and we sent them to the LLM. So here is the actual set of messages we sent to the LLM. And so we can see at the bottom, the very last question says, do my company perks cover underwater activities? And then it has a list of sources. So we're literally just sending the user's question followed by a bunch of sources to the GPT APIs. And then it knows to answer according to those sources. Right? So it's as if I had gone here and then say, what's a good place to eat in Seattle? And then I'd given it a list of potential places like, so sources, places, Pike Place, Starbucks, etc. So we're giving it the actual data as part of the question. So that's what we mean that RAG is a way of giving it the information temporarily, like so it's learning temporarily. It's part of the question, and we're just behind the scenes. When the user asks something, we're finding that data and passing it in, right? So we're basically like just we're doing the job of searching for the user, because many users aren't very good at searching. We're doing that for them and then passing them off to the LLM. All right, so that's the general approach of RAG. I think I saw a question about, is it cheaper to do RAG than fine tuning? Generally, yes, it is cheaper to do RAG than fine tuning, just because your expenses for running a fine tuned model are so much higher. So that's generally the case. Where it might not be the case, because I have read some blog posts where people said fine tuning worked better for them for RAG. So they were probably for very particular use cases. So what we usually tell people is to try RAG first, right? See how far you can take it with RAG. But then if your use case is so specialized and you really need special kinds of answers from the model and this RAG approach doesn't work, that's where you can go down the fine tuning route. But it would have to be a fairly special case for fine tuning to really make sense, or you'd have to have a really economical way of running the fine tuning model, right? So I think some people are they are running their own servers with fine tuned models. If you're comfortable doing that, and you've got the GPUs for it, great. But I certainly don't want to run my own GPT server because I'm not a GPU expert. So when we use RAG, then we can have up-to-date public knowledge because we can fetch it on demand, and we can have access to internal knowledge because we can fetch data from internal knowledge bases. So this is what's so great about RAG, and it's why I'm really excited about it. I often say I'm an AI skeptic, but a RAG fangirl. I think it's like when we combine, these LLMs with data, it's when we can, make sure that we're really creating a great experience. So when we're building a RAG, there's some general components that we're probably going to have. So we need a retriever, right? There are in RAG. So it's some sort of knowledge base that can efficiently retrieve sources to match a user query. So we'll be showing Azure AI search today. There'll be a talk later today about Azure Cosmos DB, if you're interested in connecting to that. Lots of people will just use any sort of database that supports vectors, so they can do vector search. So Quadrant, Pinecone, Postgres with PG Vector. So lots of potential retrievers. We're mostly going to be using Azure AI search because of its capabilities, and we'll see more of that. But there are many, many options. And then you could even do it in memory. If your amount of things that you're looking for is really small, you could even store it in memory or like in a file that you load in, right? Depending on how much it is you're trying to search through, you could potentially store it just in a file on, on the server. Then we have an LLM. So it's some sort of model that can answer questions based on the query and based on the sources and concluded citations. So you need a fairly powerful LLM. So we'll be using GPT-3.5 generally. You can use GPT-4 if you want, but GPT-3.5 is typically good enough for this. I can also show how you can use other models locally, such as Lava. I've used Lava. I need to try using Mistral. I do find that they're not quite as good at actually providing citations. So you're welcome to experiment with other LLMs and see if they're able to, fulfill the needs of a RAG. And then some sort of glue to glue the, chain the retriever to the LLM, right? So we get the stuff from the retriever, we pass it to the LLM. Lots of folks have developed libraries and packages for this. So you may have heard of LangChain. You may have heard of Semantic Kernel, that's from Microsoft. Also Llama Index. These are all potential libraries you could use that are built around the idea of, chaining calls together, especially calls between LLMs and retrievers. I actually don't use any of those libraries. For my glue, I just write Python code. But I wanted to point out that there are many of these glue libraries out there that, try to make it easy to make certain flows. And then for RAG chat application, you often want some sort of features, right? There's lots of features people are looking for, especially based off people already knowing ChatGPT or already knowing Git Copilot and expecting those features in a RAG chat app. So they're probably looking for chat history. So, their chats are persistent across sessions. They might be looking for feedback buttons so they can thumbs up or thumbs down. That's actually good for you to find out what's working or not. They could be looking for text to speech, which is nice from an accessibility perspective. You might want to have user login. If this is internal, you want some sort of security, either user login or a VNet. File upload, they might want to chat immediately on some file they upload. You might want access control. So there's lots of potential features for a RAG chat app, depending on your audience and use case. Okay. All right, so there are many ways to build a RAG chat application, from no code to high code. We're going to be focusing on the high code for this hackathon, since it is a hackathon, but I do want to mention no code and low code approaches because we might have folks coming in with a range of experiences. And it's also good to point out that if you don't have to write code, maybe you shouldn't, right? If a no code or low code approach works for what you need, maybe you shouldn't, to write all the code yourself. I love writing code because I'm a coder. But, that's why we have these no code and low code approaches, because it's so common these days for people to want to build RAG chat apps, and we're trying to make it easier. So we have this range of options. So first option in terms of no code is Copilot Studio. And I feel like ChatGPT has something similar with like the maybe make your own GPT. So something that allows you to write no code at all, but to set up a chat on your own data. So this is one I set up with Copilot Studio for Microsoft. I think this is limited in terms of who can use it right now. It depends on like you having a certain 365 account, but it let me basically like say what website I wanted to chat on. So I passed it my blog. It also has this ability to upload documents, set up content moderation, and then it makes this chatbot here. So that's something you can play with if you have access to it via your 365 account. And if you, think that this level of control would work well for you. The next thing is more of a low code approach. And this is from the Azure OpenAI Studio. It's called the On Your Data feature. And let me show how to get to that. So here we were in the playground, right? So when we're in the playground, we can click on Add Your Data Preview, and we can add a data source. And so when we add a data source, we can pick from Azure AI Search, if we have an existing index, Azure Blob Storage, Azure Cosmos DB. This will be shown later today as well. A particular URL, or just uploading files, right? So I could pick like blob storage, and then it can, it would tell me to pick a particular blob storage account and a container, And then it also needs an AI search resource so it can index things. So even when we say it's going to be in blob storage, like our files, it's still going to use Azure AI search to do the indexing. And then we could enter an index name, you know, my cool index. And then we set up a schedule. So when I create this, what it will do is that then it's going to look in my blob account. So an Azure blob storage account is it's just like a file drive. It's a way of storing files. It's optimized for files. So it'll look in that file drive to find all the files in there. And then it will go through them and extract all the information from them and index it and put it in Azure AI search. So I can set that up, and I set it up already earlier because it does take some time to do the indexing. So here you can see where it's connected to Azure Blob Storage and a search resource. And I told it the chunk size. So the chunk size is how big the chunks are in the search index. And this is something you're going to see a bunch, is that when you are indexing data for a RAG application, you want to you want to actually chunk the data, because you do not want to send an entire 3-page PDF to the LLM to tell it to answer based off that 3-page PDF, because LLMs, like they have limits to how much context they can handle. So you want to give it small amounts of data that has the information in it. And generally the optimal size is 512 tokens, which is about 512 words in English. And so we've actually chunked up the PDFs in sizes of 512 tokens. And those are the things that we send to the LLM. So you can see that example here. These chunks here are not the entire PDF. They're just chunks from parts of the PDF, right? So here's a chunk from page 3, here's a chunk from page 3, and here's a chunk from page 26. And usually there's also overlap between the chunks. So the best practice is to have like 25% overlap between the chunks, so that you've got, you know, just in case something is going across 2 chunks and, you know, it's awkward to split up. So generally, if you are indexing whole documents, you are going to want to do some sort of chunking in order to index them. And everything we show does take care of the chunking for you. But I wanted to point that out because it does say I did specify the chunk size. So then I can chat with it. So I can say like, okay, let's see, does it cover underwater activities? Let's see how it does with this one today. And this being an LLM, the answers are unpredictable, especially if the temperature is high. Let's see what the temperature is here. So temperature, oh, here it's going with a 0 temperature. We actually use 0.7 in our repo. So it says, it links me to particular things to check out in order to get more information here. So even if it doesn't know the answer, it does try to point me in the direction of places where it thinks I might find an answer. Okay, what does a product manager do? I see a question about optimal chunk size. Love that question. There is an amazing blog post here, which I refer to all the time. And I think we can put up the link for that. This is aka.ms/rag relevance. And they actually researched the optimal chunk size and optimal overlap. So here you can see that this is where they came up with the 512 as the optimal chunk size and as the 25% overlap. Now, this is, of course, based off the particular data they were looking at. You know, you can rag on so many different kinds of data. So it might depend on your, you know, particular data. You might find that something else works better. The other thing is, where are your boundaries, right? So they compared breaking at a token boundary versus preserving sentence boundaries. And it's generally better to preserve sentence boundaries, right? So there's this careful balance between chunk size, overlap, boundary preservation, all of that stuff. And that's the sort of thing people do write libraries for. Like Llama Index has a lot of good logic around how to do chunking. We also have logic in our repo about how to do chunking, because we shouldn't all have to write chunking logic from scratch, especially given like how much, you know, there's actually research going into this. All right, so there, oh, exceeded my rate limit. Nice. Okay, so this is using the add your data preview feature. Okay, I seem to have a real cat in this room. Okay, you need it. All right, we're gonna say hi to the cat and then say bye to the cat. This is the cat. Okay, I'll take a look at the questions. What we're saying hi to the cat. And Let's see. Okay. All right. Some good questions about chunks. And okay. So yeah. So yeah, for chunk size, good question about chunk size being independent of the GPT model. I haven't seen research that looked at it for 3.5 versus 4. I think most of them are probably using 3.5. There's also like what context size you're using, right? So for our models, they have particular context sizes. So the default context size is, I think, it's like 8,000, but we've got like, or maybe it's 4,000, but we've got 16,000, 32,000. However, the thing is that even if your LLM, does accept a larger context window, it still may not perform that well with the larger context window, right? There's another paper called Lost in the Middle. Let's see if I can find that paper. Yeah, where they research this. So, because you will see like, oh, I can just use a really big context size of 16K, 30K. You can, but what you might find is that your model gets lost in the middle, like this paper talks about. So even if your model does support sending in a larger context window, you still want to do some tests to see if it's actually paying attention to really long context, right? So that's why even with long context windows, we still recommend using smaller chunk sizes. And is a question like, do the chunks need to make sense to users? They don't really make a whole lot of sense to users just because we're not used to just reading chunks like this, but the LLM does pretty well with them. All right, great questions. I love talking about chunking, but let's move on. So this was the Azure AI Studio on your data feature. And this might be something that some of you do decide to use. We'll see another demo of it at the later session day, connecting to Cosmos DB. And, I call this low code because you do have to do, some infrastructure setup. So you'll have to, learn the Azure portal. And even if you did want to customize it further, they do actually let you download the code in order to customize it further. So this, this is an option for those of you who want to explore it. But here, this is what we're going to focus on. So we have this repo here, which, here we go. Is our open source repo. This was created by the Azure AI search team back in, I don't know, May or something like that, back for build. And it just really exploded. So we've got, almost 3,000 forks of it. It's been deployed thousands of times. It's got this huge community around it. You can see it's got 315 issues right now. It's because I like to leave issues open. It's not that there's 315 things wrong with it, but a lot of these issues are like, how do I do X? How do I do Y? And I like to leave those open so that people can see how other people are doing, certain features. We've got lots of pull requests that people, bring in. So it's a very active repo, big community. We're always, improving on it and, trying to add features that are useful for folks. So this is what we'll be mostly building off in our sessions, and hopefully what lots of you will use for your hackathon projects. It is also available in other languages. So there's a JavaScript one, and we're going to have a session from them on next Monday. There's a .NET and a Java one. They don't all have all the features that Python has. Python tends to be a little bit farther ahead just because it was the original. And a lot of times the SDKs are available in Python before the other languages because Python is such a popular language for LLM usage right now. But if you're more comfortable, like way more comfortable with these languages, you might want to check those out and see if they have the features that you need. All right, so that's our repo. And for the retriever, it uses Azure AI Search. And it does also put the documents in blob storage. Oh, wait, actually, I'm just going to call this. Here we go. There we go. So for the retriever, it's Azure AI Search, and it stores stuff in blob storage for viewing. The LLM, it defaults to GPT 3.5 because usually that's all you need, but you could use 4 if you wanted. It features multi-turn conversations. So you could ask follow-up questions. It has the option to do user authentication with access control. And it also has the option to chat with image documents. And that does use GPT-4 vision model. So If you're very interested in a particular image use case, then then you'd want to use this with that feature. We are going to have a talk about that later this week on Thursday. If you're interested in chatting with images or like image heavy documents like charts. Okay, so let's deep dive into that solution. So what do you need in order to deploy this solution? So you need an Azure account and subscription. You can use a free account. I have a demo free account that I tested it with last week. But if you do need to use a free account, then there are some limitations. And I've written up the limitations in a doc. Free. So this is a doc that describes how to deploy with minimal costs, and this might be what you want to do for a hackathon situation. And it describes the limitations when you describe with minimal costs. So this isn't our default, so that's why you have to customize some things. But this may be what you want to do when you're prototyping. You can read about the limitations, and then specifically if you're trying to deploy from an Azure free account. Which is also an Azure student account, I think is also an Azure free account. I know many of you have Azure student accounts. You unfortunately right now cannot access Azure OpenAI. And that's just because there was so much abuse when Azure free accounts were able to access it, and they're trying to work on, enabling it again while also not having abuse, because we don't, we want to be responsible. Microsoft has a responsible AI policy. We want to be responsible. So they're working on being able to enable it for free accounts. What you can do for now is that you can use openai.com, and that works fine. You just specify your OpenAI key. So that's probably what you want to do. What I'm going to do later today is record a video of me doing this deploy from my free account, and I'll post that in the discussion and also in this README here, so that you can just follow along and see exactly how I do a free deploy from a free account, because I imagine that's going to be fairly popular thing to do. All right, so you need the Azure account and subscription, and then either access to Azure OpenAI, so you can request access to it via this form here, or if you can't get access to it for whatever reason, you can totally use an openai.com account. They're pretty similar APIs. We have support for both of them. Azure OpenAI, does have some other features where it also has this content safety filter. OpenAI.com doesn't have that, but for the purposes of this, this repo, you can use either of them. For getting started with a project, you have three options. The first option, which I usually recommend, I often recommend if you have any doubts about setting up locally, is to use GitHub code spaces. So let me show that. I actually already have it open here, but the way you do it is you go to the repo and you click on the code button, and you need to be logged into a GitHub account. And then you can go ahead and make a code space. So I can create a code space. And that actually started really quickly. Okay. So what this does is actually creates a containerized environment in the cloud using web-based VS Code. So this is pretty cool because it's going to have all the requirements already set up. So it's going to have the right version of Python. It's going to have the right version of Node. It's going to have the AZD CLI. All this stuff will be set up in this environment for you. So I love using GitHub code spaces because it does set up everything for you and you don't have to worry about your local setup. So this can be a really great option. There's a limit of 60 hours a month of using code spaces. So if you do think you're going to go over that when using this, use for this hackathon, then you might want to set up locally. But you can always push your changes to a fork and then run it locally. So here's code spaces. So it's already set up. So it means, we should be able to run Python 3 and we're in 3.11. We should be able to run, Node NPM commands as well. And all of that stuff is already set up. So that's option one. Another option is to use VS Code with the Dev Containers extension, because then it will set up everything for you. For that, you also need Docker Desktop. So if you've never used that before, you might not want to start today, but if you do use VS Code with dev containers, we do support that and have everything ready to go, and that'll set up everything for you. Otherwise, you can use a local environment, and it is possible you are going to have Python 3.9 or a greater. I usually use 3.11 or I usually use 3.11, Node 14 or greater, and the AZD CLI. So this is also an option if you're, if you want to set up your local environment. So those are the 3 ways to get started with the project. And then once you're in the project, the first thing you want to do is actually deploy. And we need to first deploy because we need to set up the resources so that we can work with them locally. So in order to deploy, we're using the Azure Developer CLI, which is AZD. So all the commands start with AZD. And the first thing you need to do is log in. So from a code space, I'm going to try doing it in the code space just to show you. We'll see AZD off login. And then I'm going to use this feature, use device code. We have to do that when we're in a code space since we're inside a browser and the login's a little different. So what this does, it gives me this code. So I copy that and then I press enter. And then I enter the code displayed. And now I'm going to have to go through a lot of hoops because I have a very well-protected account, which is good. But it does mean I have to go through a bunch of steps here. Okay, Microsoft. All right. And then I'm going to bring up my 2-factor and put in the number. Okay. All right. I showed it my face. Okay. Are you trying to sign into this CLI? Yes. Whew. All right. So that I've done the login dance. And it says I'm logged into Azure. Very good. The next thing we can do is create a new AZD environment. This is basically like a resource group for all of the resources that are going to be made. And you can have multiple AZD environments. So locally, I actually have something like 20 environments because I do a lot of different kinds of deploys of this one. But all of you might just have, a single environment that you deploy to, a single resource group. So I'll enter a name, which is like cool cat. No, cool cat chat. So it'll just become the name of your resource group, right? So a better name would be like ragchat. There, that's a good name. All right, so we created that environment and then we do AZD up. So what this does is it looks at our bicep files. We have all these bicep files. Bicep is a kind of infrastructure as code, which is like Terraform, but it's basically a bunch of files that declare the resources that we need to make. And it looks at that to figure out what Azure resources it's going to make. So let's see. First, I need to select my subscription. Most of you probably only have a single subscription. I have a bunch just because of Microsoft, but most of you is probably just going to be a single subscription. Then you select an Azure location to use for most of the resources. So I could try, like central. Well, I guess we'll just do East US too, see how that goes. Sometimes you will get availability issues with some of the resources. Like the document intelligence one sometimes has limitations. But generally you want to pick a region that's close to you. That's the usual best practice, is to pick a region close to you. Now, the first thing it's doing is packaging up the backend. So it's actually right now compiling the React JavaScript files. So let's see, I think it did that. Now it is, it's doing a little more building of the JavaScript files. So that takes a little bit of time. So it's packaging that up. And then it's going to copy that into the backend folder. So here you can see there's a backend folder and a frontend folder. So the first thing it does, it builds that frontend folder and creates the JavaScript files and then copies it into the backend static file, a static folder here. So you can see this has all the compiled JavaScript, right? And that's what we end up deploying. So when this deploys at the end, it's just going to deploy this backend. All right, now we need to enter a value just for the OpenAI location. The reason we have to specify a specific location just for OpenAI is because there is such limited availability region-wise for OpenAI models. So, once again, I'll try East US 2 and see if I have any issues with that region. But a lot of times you might end up wanting to do a different location than your original one if your original location wasn't supported for OpenAI. I see a question about AZDM versus conda-env. They are actually completely different things. So if you're used to Python with like conda and virtual env, that's a way of managing your Python virtual environment, like your Python packages. And we do create Python virtual envs in here. So there's one, there'll be one in here and one in here. But AZD environment is just about your like Azure resources and what's going to get deployed to a particular resource group. And those are actually stored in this .azure folder. So you can see one was made for my AZD environment. So an AZD-env is not the same thing as a conda-env or a virtual env. They're unrelated to each other, and you'll end up having both AZD environments as well as Python virtual environments. All right, and now you can see that it is actually creating the resources, and it's going to show progress bar for as it goes along. And so you see it makes a resource group, which is called rg-ragchat hack. So it used our environment name, and then it makes a bunch of resources just with this generated unique string here. So it's made the app service plan, Azure OpenAI, form recognizer, application insights. Now it's making the search service. So this can take some number of minutes. Like it can take, I think, maybe 12 minutes these days to make all those resources, because it is creating new Azure resources for you in a particular data center, in that region. And some of them can take a little bit of time to set up. Okay, so while it's doing that, let's talk about the application architecture, right? So how does this application actually work? So we have first, when we're deploying it, we have the data ingestion phase, and we generally use a local script to do that. And what that does is that it looks at your local files, right? So for example, I've got these files here, right? The benefit options, employee handbook, perks plus, role library, etc. Right? So it looks at each of those files. It uploads each of them to Azure Blob Storage. Then it uses Azure Document Intelligence to extract the data from the PDFs. There's also an option to use a local PDF parser here, which is going to be cheaper to do something locally. So, but either way, you need some way of reading those PDF files and getting the data out of them. Then we have some Python code that does the chunking. So we're actually, we've got our own, splitter, we've got our splitter here, our chunker. It's a lot of logic, a lot of code in order to figure out those chunk sizes with the overlap. So we split that data into chunks. Then we take each of those chunks and we compute a vector embedding for the chunk so that we can later do a vector search. And that'll get us better results. So we take each of the chunks, compute the embedding, and then finally we store both the chunk and the embedding in the index. So I can show you what the index looks like. Let's see, in the portal. All right, so I can take a look at this index. Actually, I'm going to do a different one. I'm going to do this one and take a look at the search service and look at the index. And here's the index. I'll search for all of them. Okay. So this is what our index ends up looking like, where we've got each of our chunks is what's called a document in the index. But you remember, each of our actual documents got chunked into multiple of these. So here we can see the content, which is the text content. Then we see the embedding, which is a vector embedding. So it's a bunch of floating point numbers. And then you can have a category if you want. We usually don't use that. Then the source page, which is what page number it came from. And then the file, which is just the file name it came from. So this is what it's going to end up looking like in Azure AI Search. And that's what we'll end up searching. Okay, so that's the data ingestion script. So then, once our search index is made, then we can actually use our app. So what does our app do? It uses Azure OpenAI, and it uses Azure AI Search and Azure Storage. Those are the three things it uses. And you can see that, see that here, right? When I click on here, it's going to open up the file, and it's getting this file from blob storage, right? So that's why we're using blob storage, in order to actually store the files. And then we're using OpenAI in order to actually, answer the question, and we're using Azure AI search in order to get these search results, right? So first we get the search results here. And this is actually, these look just like what I showed you in the portal, right? So we get 3 search results for the query, and then we pass those to OpenAI in order to answer the question. So that's our, our live app application architecture, what we need for it. So in terms of understanding the code, this is a general layout of the code so that those of you who do want to get into the code can, start from these files here. So on the front end, we have chat.tsx, which has a function to make an API request, and that goes to api.ts. All right, so if we look at api.ts, we can see that that has a fetch to the /chat URI. And so that is handled by the route in app.py. This is our Python code, and that's a post request. And so it processes, the parameters, and then it gets sent to one of our RAG approaches. So we actually have 4 different approaches, but this is the default, which is chat read retrieve.py. So it, takes in those parameters, and it will get the search results, and then get them any messages from the chat history, and then it will send them to OpenAI and ask for the answer. So that's a very high level overview of the code. And I know I went through that very quickly because we only have so much time today, but we can look at it more in tomorrow's session. And we're also going to go more in depth in a future session on Wednesday about the search approach, because one thing I do like to point out is that for our search approach, we generally recommend using hybrid retrieval. And you can see that is an option here where we say retrieval mode, and I say vectors plus text hybrid, and then also use semantic ranker. This is the best practice as well, because you're going to get the best results. This blog post that we talked about earlier covers why that's generally the best approach, and we'll also talk about more at Wednesday session. But the general idea is that when we're doing a search, we're searching both on the text, like doing a keyword text search, and we're searching using a vector search, which gets us like this semantic similarity between things, and that helps us get the best results overall. Okay, so we've got 3 minutes left. So let's check to see how our deployment here is still going. So you can see it does take, a bit of time to make those resources. So this is when I usually go off and, drink tea, especially today. I have ones I did earlier, so I can show you earlier what it looks like when it's done. Right, so it'll create all those resources, and so that you'll have those resources created in your portal. And then it will do the data ingestion. So this is what data ingestion looks like, is that it, runs this prep.docs.py, which does the ingestion. It'll check if it needs to make the index, and then it'll start going through each of the documents, splitting them into sections, uploading their blob, and then computing the embeddings for each of those sections. And so that takes a little bit of time as well. And of course, this data is all our sample data, right? And, you're in the hackathon, you want to build an app on your own data, right? That's, hopefully why you're here. So that's what I'm going to be talking about in tomorrow morning session, is customizing your ragchat app. So we'll talk about how do we customize the front end, how do we customize the back end, how do we customize the prompt, how do we bring in our own data, right? So we'll talk about all that tomorrow. So we'll have lots of time to go into that in more details. My goal for today is to hopefully get all of you figured out, like, what account you're going to be using, figuring out how to do a basic deploy, right? That's what I want to make sure, is that everyone is able to just get this basic one going, because then you can build off of that. And I know there were a ton of comments and questions in the chat, and I only got to a few of them. So, please do post those in the discussion forum, anything we didn't cover. And I will also, record videos of anything I didn't get a chance to show you, like showing you how to do a free deploy, so that we can help you all be successful. It's now 10:59. I'm happy to answer questions now, because I have time, but we are also at the end of our session. So I'll defer to Josh and John for next steps. Let's see. Yeah, great question, Jason. Will any sessions cover authorization practices? So let's take a look at our upcoming schedule, and I can point out which ones. So we have access control in ragchat. So that is going to be from Matt Gottner. Matt is the one that actually wrote the authentication and access control for the app, and he's from the AI search team. So he's dealt with this a lot. So that will be on Monday. So do join us on Monday if you're interested in authentication and access control. And let's see. Okay, and I was talking about doing the free deployment. So let's bring up these next steps, right? So next steps, if you aren't registered for the hackathon yet, register for it. If you haven't introduced yourself yet, we've got an introduction thread and discussion forum. That's also where you can ask any additional questions. And then you should try to deploy the repo with the sample data. These are the instructions here about free, doing it with minimal costs. Oh, that's not going the right place. Okay. Let's try that again. Ragchat free, this one. Okay, here we go. So here's the instructions about deploying with minimal costs and deploying from a free account. So I will, as soon as I have time today, I'm going to record a video showing myself doing this. So I'll try to do that ASAP this morning, just so for those of you who want to just follow along, but you can also just follow the steps, right? You just run some AZD commands and then you run AZD up. But I can show it also with openai.com. So this is what I mean is deploying with minimal costs. You're going to want to follow this README if you're trying to use $0 basically, which is always great. But there are some limitations, so I do recommend looking through these. And yeah, next steps: posting in the forum if you have any questions or issues deploying, and then joining. We've got the session later today for connecting to Cosmos DB for any of you interested in connecting to like an existing database. And then we've got the session tomorrow where I'm going to go into customizing your app with your own data, your own UI, all of that stuff. The recording will be available for this session. I'll also post a link to these slides. I'll upload these slides so that you'll have a link to this slide as well. Our cat doesn't even use litter. Our cat goes freely into the outdoors and just does his thing. All right, great. So yeah, please do post in the forum for any questions we didn't cover. I am happy to just go through and answer a bunch of them after. So thank you everyone for watching, for all the great questions and comments. And I hope to see you later this afternoon at Kellen's session or tomorrow morning at my next session on customizing. Bye everyone.